Okay, there's this weird delay before the stream actually starts. Not sure what the delay actually is. I think it differs as well, but yeah, I'm still waiting on another device to see if the stream is coming through or not. Just checking if we're using the correct microphone and stuff. Yeah, seem to be using the good microphone. So that sounds good. Just post on socials just in case someone wants to join in. Join me and ChatGPT live on YouTube. Okay, we have the link and everything. Last time we actually had to block someone. Because, yeah, when I say you can join in and have a chat, say what you like, whatever, but then actually someone reported one of my videos as misinformation. And obviously it was the one on, what was it? The neurofeedback stuff, yeah. And all the snakes started coming from under the rock. So that's not fun. You have to shut them early on. Even though that person said they're willing to chat, I actually had a discussion. There was no information in the video. I just had a conversation with ChatGPT about neurofeedback. Yeah, it wasn't in favor of neurofeedback, but it just, the way it is. But then the person said they're willing to have a nuanced conversation on the topic, but then they already reported the video, so so obviously didn't come across as genuine. So yeah. Anyhow, moving on. Keep rearranging my windows and stuff because I have like a zillion of them open. Too many windows. Give me a sec. Yes, eventually we editing the live streams into shorter videos, so stay tuned. Yes, people don't have time to watch the whole thing and find the necessary bit. Yeah, we'll be addressing that for you. So you can actually find what you want to find. Eventually all these tools are available on this website, bionicchaos.com. Go check it out. There's a lot of more. There's quite a lot on it already. There's all sorts of blogs. In this case, instead of using this funny AI generated images, we're actually using knowledge graphs instead of the figures, instead of the images. So hopefully they're actually a bit more useful for the topic. I don't know why in this case it was twisted. Could have been untwisted, this one as well. But yeah, it's talking about EEG, obviously, in relation to mental health. And explained, so mental health explained through engineering. So again, this blog was written after or during a conversation with ChatGPT. So as everything else on the website, generated using ChatGPT. We have some more datasets that we are looking into. We're more already doing image processing on EEG data. EEG data, yes, I know it sounds weird because EEG data is time series, as you know or don't know, then you should know. But then it can be any time series data can be translated into an image, for example, by using a spectrogram. And this is what was this data all about. And we were doing detection of seizures. And we had the 600 images in non-seizure and seizure. And you can see all the training, all the results on the site with all the test accuracy, and all the code will be at the bottom of the page as well. So yeah, all the Python code for training this model. The data is public. It's available on somewhere online. There's a link there. Yeah, on PhysioNet. You can go fetch the images, the data for this training. Then the results of my training are available here. This one was also used about 2, 3, 4 years ago in another paper, so you can compare results. We were actually benchmarking against that. I think we did a bit better. So everything is there. The code for training, the dataset is public, and my results. So go check it out. And then we'll be doing similar thing for another dataset to do with breast cancer. So we'll have malignant, non-malignant images, so cancer, no cancer. And again, does the binary classification. In this case as well, the MNIST, MedMNIST dataset is available in the public domain. Everyone can access it and train their own models on it. And this one just explaining how you would go about it. Getting the data, visualizing, model training, and interactive results. So in this case, we want to take it a step further and actually have an option where you could upload an image. It's essentially will be a mammogram and an X-ray of the breast, and it will tell you what the probability is like for it being malignant or not. Obviously, we'll have to have all the necessary disclaimers for that. That's not available yet, but that's the kind of stuff we're working on. Just another topic, just throwing everything into the mix. Just a fun one, a quick one. So supposedly ChatGPT cannot draw a full glass of water or wine or whatever it is. And yes, that seemed to be the case. Yeah, there's a big, another big YouTuber tried it, and essentially suggesting that because ChatGPT was trained on all these images, I heard this argument before. Apparently ChatGPT cannot draw an image of a person writing with the left hand. Same thing, we can try that one as well. But the point is that if you actually Google search this stuff, it does show you images of a glass full. So obviously there's some problem in the training. If it really cannot, yeah, I tried a few times. Apparently many people tried, and apparently it cannot do it without. But yeah, seems like people are always on the lookout for something a tool cannot do, as opposed to focusing on what it can do. And what it can do is can generate this code. So obviously that big YouTuber, I forget the name, it was actually suggesting that ChatGPT doesn't know what a glass full to the rim looks like. Therefore, it cannot generate that image. But the fact of the matter, it's obviously it does know what it is. I mean, this thing been my CEO for the last 2 years, so hopefully it is smarter than that. And actually it is, because if you ask it to generate vanilla HTML and JavaScript and SVG image that simulates water filling, it actually does the job. And guess what? Do you think it will be able to, would I be able to fill the glass up to the rim? Maybe. Yes, we can. So it generated the code from scratch. The image is SVG. Yes, that SVG is not great. We actually took this into a better model, the better in programming. So that model, supposedly the O3 Mini High, is great at coding and logic. So yes, if we give it the same prompt, vanilla HTML, JavaScript, and SVG image that simulates a glass fill with water using a slider, make the glass look realistic, it generates this image, which we cannot run on the thing. We have to copy paste into Visual Studio Code, whatever, locally. And when we run that one, it does another simulation that does look a bit better, where we can actually fill up the water all the way to the rim. So obviously ChatGPT does know what a glass fill to the rim looks like. It's actually quite obvious even from the chat as well, from the language model, that it actually does understand, because it can describe it to you in quite a detail, including explaining surface tension and stuff like that. So yeah, there you go. It's also a ChatGPT generated, so it seemed to do know what's a glass fill to the rim looks like. Because obviously it can do like research for you and stuff. We're actually looking at the ECG deep location system for central venous catheter placement. We intentionally told it not to mention any company names, but yeah, you can imagine there's a reason why we're looking at this one. And it can do a pretty decent job describing and actually giving a practical and critical review of the the tool, what's currently being used, accuracy. It now seemed to get the references and citations correctly. Those links actually do work. I don't want to click on them due to potential copyright issues, so we won't be going there. But it's supposedly whatever ChatGPT generated based on our own prompts. We had a previous quite a lengthy discussion with the thing, and it can actually do quite a detailed, nuanced analysis of literature. And in terms of images, yeah, we asking the chat model, in this case 4.0, to suggest a relevant image, and it actually did that. So it looks pretty decent. I don't know why they need a stylus pressing on that button. Yeah, once you look at the details, it's all how you're doing. It's out of sorts. Same for generating videos. So we actually had a similar prompt for a video, and it's doing a pretty decent job as well. And no, that baby is not real. Yeah, by the way, now on Blue Sky as well, you're on it as well, go check out the Blue Sky. It's pretty much will be similar to what we get on YouTube, but yes, it's a replacement for Twitter, which, yeah. Yeah, now we'll go over the website. We want to release this into the wild. Yeah, wanted to mention it's generated by ChatGPT. Yeah, because the point of the images, I don't know if SVG, does SVG consider to be an image? Now, yeah, so, okay, let's go back quickly to this research for a sec. Question if when we start the chat, if we start the chat, can you summarize the research again? Don't mention any company names.
Summary of research on ECG tip location systems for central venous catheter placement. Background and purpose. ECG-based tip location systems have been developed to improve the accuracy and safety of central venous catheter CVC placement, particularly in neonatal and pediatric patients. Traditional methods rely on anatomic landmarks, ultrasound guidance, and chest x-rays, each with its own limitations. The goal of systems is to provide real-time feedback during catheter insertion, reducing the reliance on X-ray confirmation and minimizing placement errors. Key findings and clinical validation. 1. Accuracy and efficacy. Studies indicate that ECG-based methods achieve high accuracy rates in detecting catheter tip positioning within the superior vena cava, SVC, right atrial junction. Research comparing ECG guidance versus traditional imaging methods has shown a strong correlation between
can we have a
ECG
continuous
waveform
conversation
changes
about it
and correct
instead of
catheter
you
placement.
just giving me a
2.
lecture?
Reduction in complications. By ensuring
Can
precise
you?
tip positioning,
Can you?
ECG guidance reduces risks such as catheter misplacement, migration, and vascular perforation.
Yeah, that model is not great. You can't actually freely chat with it. Let's try a different model quickly. It doesn't have screen sharing as well, which you do have on mobile, which is quite unfortunate. We could have used it quite a bit. Hey, we are live streaming at the moment. Can you be a co-host for this session, addressing the viewers directly? Short responses, make it fun and quick. Talk quickly as well.
Absolutely. Hey everyone, how's it going? Let's dive right in and have some fun.
Okay, I'm still the main host, okay? You're just co-hosting.
Got it. I'm here to support you and keep things lively. Let's do this.
Okay, if you also can remove any fluff, that would be great. Hey, can you jump straight in? Do you know what central venous catheter placement and how it's currently being done? We're primarily looking at the ECG deep location. Do you know anything about it? Just a quick response.
Sure thing. Central venous catheter placement involves inserting a catheter into a large vein. For ECG tip location, the catheter's position is confirmed by analyzing specific ECG waveforms. This helps ensure accurate placement in the superior vena cava.
Okay, so what is it currently being? Is ECG currently being used in a hospital? What's the current gold standard for doing this? Just a quick response, make it fun and critical. Don't mind the dark humor.
Absolutely. ECG guidance is indeed used in hospitals and is quite the gold standard for central venous catheter placement. It's like the GPS for your veins. It ensures precise placement, reducing the need for x-rays, and making the process smoother and safer.
I'm not sure about that. Are you sure it's actually being used in what's the current gold standard for placing a catheter? It's searching.
As of 2025, the gold standard for placing central venous catheters is the Seldinger technique, performed with real-time ultrasound guidance. This combo is like the dynamic duo for accuracy and safety.
Okay, and so ECG, is it using ECG? No.
ECG guidance can be used alongside ultrasound for confirming catheter tip placement, but ultrasound is the primary tool. ECG might be used in some settings, but ultrasound remains the gold standard.
So why is it the gold standard as opposed to using ECG alone?
Ultrasound is the gold standard because it provides real-time visualization of the vein and surrounding structures, making the procedure safer and more precise. It reduces complications and improves success rates. ECG alone can't offer that same level of detail.
Why not? Just a quick, fun response.
Because ECG alone is like navigating in the dark. Ultrasound lights up the path, showing exactly where to go and avoiding any unwanted surprises.
Okay, can you give a better analogy?
Sure. Think of ECG alone as trying to find your way with just a compass, while ultrasound is like having a GPS with a live map. Much clearer and more reliable.
So what are the problems using ECG? Is it used in addition at the moment in hospitals or not used at all?
ECG alone can have limitations like less precision in confirming exact catheter placement, especially in complex cases. However, it can be used in addition to ultrasound for extra confirmation in some hospitals.
Can you give an analogy, compare this to what's currently being used to diagnose epilepsy?
Sure, using ECG alone is like diagnosing epilepsy with just patient descriptions, while ultrasound is like having an EEG for direct brain activity monitoring. Ultrasound provides a clearer picture and confirmation.
Wait a sec, wouldn't ECG be more equivalent of using EEG?
You're right. A better analogy. Using ECG alone for catheter placement is like diagnosing epilepsy with only a patient's report of symptoms, whereas combining it with ultrasound is like adding an EEG for a complete, accurate diagnosis.
Now you're now going in the loop, so EEG is more similar to ECG, isn't it?
Yes, exactly. ECG and EEG are quite similar in their roles, both providing electrical activity monitoring, ECG for the heart and EEG for the brain. Ultrasound, on the other hand, provides real-time imaging, adding that extra layer of precision.
Yes, so going back to the epilepsy analogy.
Got it. In the epilepsy analogy, using just ECG for catheter placement is like relying solely on patient symptoms for diagnosing epilepsy. Adding ultrasound is like using EEG for a clearer, more accurate diagnosis.
Okay, The analogy is really confusing because EEG is similar to ECG. So can you improve the analogy?
Of course, using ECG alone for catheter placement is like diagnosing epilepsy just by observing symptoms, while adding ultrasound is like using imaging to get a full, clear picture. It's about adding more precision.
Okay, it's a bit hallucinating on me there. It's amazing how the different models seem to perform quite differently, and I'm not sure why yet. Yeah, I'm not entirely sure what the difference between the different models and when to use which one. So yeah, let me know if you experienced something similar. Yeah, let's actually start a new chat. We'll do a project. So we'll add a new project. It's called so ASM is arrhythmia. This is anti-seizure medication. So anti-epileptic drugs. Well, yeah, anti-seizure medication is a much better name because there is essentially no medication to seizure. So it's sorry, no medication to epilepsy. It can not 100% cure epilepsy as far as I'm aware, but it can reduce the number of seizures. So address the symptoms. But yeah, we really should have an expert talking about it instead of myself. But we are just trying a project function in ChatGPT. So we're uploading these files. Yeah, it's comparing different studies, but yeah, we get the bot. Yeah, we can use canvas with just on the regular 4.0. Just see what's its limit before using any reasoning models. Okay, so I have this project. There's a bunch of files. Can you give a quick overview of what each file is? Okay, so we have the two CSV files.
These are datasets related to epilepsy patients, potentially containing patient demographics, treatment types, and outcome measures.
Well, why potentially? Why didn't you actually check the file? So there's a bunch of visualizations. Okay, we're not modifying the scripts yet. We just need an overview of the data first. So did you actually parse the CSV files?
Chat history. Use set project so we
Yeah, it's actually using Python to... It's using pandas now. Yeah, we're using pandas. And it's having errors. Yeah, don't like it.
well-structured CSV with 4 columns: category, metric, value, unit, and additional info.
Okay, so from memory, we will start fresh. Yeah, we want to generate a HTML for displaying all the data, visualizing the results of our Python script as well. So in the Python files, first of all, if you can generate the template HTML for displaying all the results in this folder, that will be great. Now the question, I assume that we will need to store all the graph outputs from the Python code as images. Is that correct? Okay, so we're getting a template HTML and modifying the scripts to actually generate to save the plots as images. Yeah, that seems to know what to do, and this is not the reasoning model. It's just for all. And why on earth it's rewriting? What are they doing? Wait. It's rewriting my canvas. Okay, well, anyway, need an index HTML. That's the a template for it. Yeah, it's missing a lot of stuff. Modify the Python, yes, but do it in the new canvas. Should in theory close this one if I see it's rewriting. Yeah, it seemed to be doing a new one, so that would be the replacement for, yeah, matplotlib and pandas. Yeah, using OS to store the files, to write the files. Don't like the names of the functions, they're too long. Not yet. This is obviously replacement for the main Python code. We had 115 lines of code, and I do not expect this to be shorter. Or maybe because it's not displaying the plots. We're not reading anything, just want to see it. So just run the thing. Now we're getting all these errors. And why it cannot find the CSV file, it's in the same folder. Hey, can you use all the 3 files? And the exact location, keep it the same location. This is the previous code that used to work and generate the graphs correctly. Can you have a look? Yeah, maybe because we're not using a reasoning model or something. It's modifying my code already. Didn't actually ask it to, just ask it to have a look, but okay. Okay, generated. Hey, regenerate the code, but
I fixed the issue in the create hazard ratio plot function by ensuring the zero values are correctly aligned with hazard ratios. The script should now generate the visualizations correctly. Let me know if you run into any further issues. Rocket.
not sure what the emoji there, but okay. Can we run it? No, we can't run it. It will installing packages. Nah. Yeah, I don't know what you're doing. But it would, yeah, it would not have the CSV files. Okay, let's try to no, I don't know why it's even giving that option. It should recognize that that's not a code that can run on its own server. Let's try it again. It should have. Generated images. Did you put it in the main folder or something? No. Yeah, it popped them into a different folder. Yeah, the static images. It's stuffed up my folder. And let's just pop them into static. Okay. I think we are in business. They be able to fix it in the canvas as well. Obviously, we can't run it locally. Now we should have to okay, can we update the HTML, the visualization dashboard, to include the images we generated? Can you also in the chat make a comment if we should just turn it into JavaScript and not use Python? So the visualization dashboard can actually be interactive.
I've updated the image paths in your HTML to use the correct directory as MVS or hivmia/static/. Should we use JavaScript instead of Python for interactivity? Python matplotlib/static images. White heavy check mark easier to generate reports and save figures. Cross mark not interactive users cannot zoom, hover, or filter data dynamically. JavaScript d3.js, chart.js, plotly. White heavy check mark allows real-time interactivity hover tooltips, zoom, filtering. White heavy check mark works directly in the browser without regenerating images. Cross mark requires restructuring the visualization logic. Recommendation: if interactivity is a priority, switching to JavaScript, e.g. plotly.js or chart.js, is a great option. We could load CSV data into the web page using JavaScript. Render dynamic, interactive charts instead of static images. Would you like me to convert the dashboard to JavaScript-based visualizations?
Yes, so yeah, the text-to-speech is not great. Let's try the Ava text-to-speech quickly.
I've updated the image paths in your HTML to use the correct directory, achems arrhythmia static. Should we use JavaScript instead of Python for interactivity? Python, matplotlib, static images. Easier to generate reports and save figures. Not interactive. Users cannot zoom, hover, or filter data dynamically. JavaScript d3.js, chart.js, plotly. Allows real-time interactivity, hover tooltips, zoom, filtering. Works directly in the browser without regenerating images. Requires restructuring the visualization logic. Recommendation: if interactivity is a priority, switching to JavaScript, e.g. plotly.js or chart.js, is a great option. We could load CSV data into the web page using JavaScript, render dynamic interactive charts instead of static images. Would you like me to convert the dashboard to JavaScript-based visualizations?
Okay, can we actually use JavaScript to load all the data as tables to begin with? So all 3 CSV files loaded into the dashboard.
I've updated the HTML to load and display all three CSV files, epilepsydata1.csv, epilepsydata2.csv, and combined.csv as tables in the dashboard using JavaScript. The script fetches the data dynamically and renders it in tables within the HTML. Now, when you load the page, it will automatically display the contents of the CSV files in table format. Would you like me to enhance this further with sorting, filtering, or interactive features?
I think we might be having an issue with the combined table. Hey, can you actually look at the 3 CSV files for me? Hey, can you also in the chat give a continuous text overview of the data? In the chat.
After inspecting the CSV files, here's a summary of their structure and any potential issues. Columns, category, metric, value, unit, additional info. Structure contains patient characteristics such as total patients, median age, and age interquartile range. Issue, no apparent problems. Structure contains case control counts, gender distribution, and other categorical patient statistics. Structure, this file is not a traditional CSV but rather a markdown-style table using as separators. Columns include study names, publication years, sample sizes, median ages, percent female, ASMs used, key findings, and other notes. Issue, this file must be parsed differently since it's formatted as a table with rather than a standard CSV format.
Yeah, we need to parse the data differently. Can you actually use search and find the papers mentioned in the combined CSV? Yeah, the problem with that thing might start a new 4.0 chat if search. Don't have the name for the paper. It was need to include the name for the paper and parse the results from the paper in a better way.
Based on the available search results, I have located and reviewed the following studies from the combined CSV 1. H. et al. 2025. This study, titled Association Between Anti-Seizure Medications and Cardiac Arrhythmias in Patients Undergoing Ambulatory Electroencephalographic and Electrocardiographic Monitoring, was published in Seizure in 2025. The researchers conducted an observational study with 3,695 patients undergoing ambulatory video EEG/ECG monitoring. They found that 28% of patients experienced cardiac arrhythmias, with non-sustained supraventricular tachycardia being the most common, 19%. Notably, the use of carbamazepine, lamotrigine, and lacosamide was associated with a reduced occurrence of cardiac arrhythmias. No anti-seizure medication was linked to an increased risk of arrhythmias or significant changes in the QTc interval. Cite-turn-search for CEP. 2. Wang et al. 2023 in the study Epilepsy and Long-Term Risk of Arrhythmias, published in the European Heart Journal in 2023, the authors analyzed data from 329,432 individuals, including 2,699 with epilepsy, from the UK Biobank. They reported that individuals with epilepsy had a higher long-term risk of cardiac arrhythmias, HR 1.36, atrial fibrillation, HR 1.26, and other arrhythmias, HR 1.56. The increased risk was particularly evident among those using carbamazepine and valproic acid. Genetic predisposition did not modify these associations. Cite-turn-search 3 flash. Unfortunately, I was unable to locate specific information or access the full texts for the following. Upon further investigation, I have located and reviewed the following studies from the combined CSV 1. Lee Lane et al. 2021. This retrospective matched cohort study, titled Epilepsy, Anti-Epileptic Drugs, and the Risk of Major Cardiovascular Events, was published in Epilepsia in July 2021. The researchers analyzed data from 10,241 individuals with epilepsy prescribed anti-epileptic drugs, AEDs, and 35,145 matched controls. Over a mean follow-up of 6.1 years, they found that individuals with epilepsy had a significantly increased risk of major cardiovascular events compared to controls. Adjusted hazard ratio 1.58, 95% confidence interval, CI 1.51 to 1.63, p.001. Importantly, there was no notable difference in cardiovascular event risk between those treated with enzyme-inducing AEDs and non-enzyme-inducing AEDs. Adjusted H.95, 95% CI, 0.86 to 105, p equals 0.30. The study emphasizes the importance of cardiovascular risk management in the clinical care of people with epilepsy. Cite-turn-search Kroll 2. Cross et al. 2024. In the study, sudden cardiac death or ventricular arrhythmia in patients taking levetiracetam or oxcarbazepine, published in 2024, the authors assessed the potential association of levetiracetam with cardiac outcomes related to QT interval prolongation. Utilizing data from 104,655 levetiracetam users and 39,596 oxcarbazepine users, the study found no significant difference in the rate of sudden cardiac death or ventricular arrhythmia between the two groups. Hazard ratio HR 0.79, 95% CI 0.42 to 1.47. These findings suggest that levetiracetam does not correlate with an increased risk of ventricular arrhythmia and sudden cardiac death compared to oxcarbazepine, and do not support the need for cardiac monitoring when prescribing levetiracetam. Upon further investigation, I have located the study by Lee et al. 2024, titled Risk Assessment of Arrhythmias Related to 3 Anti-Seizure Medications, a systematic review and single-arm meta-analysis, published in Frontiers in Neurology. This meta-analysis included 11 clinical trials with a total of 1,031 participants, evaluating the incidence of arrhythmias associated with lacosamide, LCM, levetiracetam, LEV, and perampanel, PR. Key findings. Lacosamide. The pooled incidence of arrhythmias was 1.4%, 95% CI, 0.3 to 3.0%. The study found that LCM significantly elevated the risk of arrhythmias. Subgroup analysis indicated that a fixed dosage regimen was associated with a higher incidence compared to a stepwise dose increase. However, publication bias was noted in the LCM group, and adjustments using the trim and fill method yielded a similar pooled incidence, suggesting the findings are reliable. Levetiracetam. The pooled incidence of arrhythmias was 0.5%, 95 per CI 0.1 to 1.3%, indicating non-significant arrhythmogenic effects. Dosage variations did not significantly impact the risk of arrhythmias associated with LEV. Perampanel. Due to insufficient data, a meta-analysis for PAR was not conducted. The systematic review highlighted the need for more clinical trials to assess arrhythmogenic potential. The study underscores the importance of monitoring cardiac function in patients with epilepsy, especially when prescribing LCM due to its associated higher risk of arrhythmias. Clinicians are advised to consider these findings when selecting anti-seizure medications and to remain vigilant for potential cardiac adverse effects. For a comprehensive understanding, you can access the full study here to use intervention link frontiersin.org/articles/10.3389/FNURI 224-12953/8/full.
Okay, so we're asking for one data file with all the studies. You have the study name, sample size, monitoring duration, percent of anti-seizure medication, median age, percent female, publication name. What? No, I meant. Hey, can you also include the name of the study? Hey, can you include the name of the paper, the title? Can you include the title of the paper as well as in a separate column? Yes, a separate sub item. Okay, we might continue this next time. We will also extract the. Yeah, next time we'll be extracting the key findings and the results of each paper. Hey, can you also can you generate another JSON file that will just have the study name and then the key findings for each drug, essentially all the detailed results in separate items of the JSON file. Yeah, we need this in some sort of numbers so we can actually compare the studies. This one's just a text description, but it's not great because we're not able to compare. So do you have any suggestions as to how we can actually compare the results from different studies and make that JSON file better? Okay, I'll see you next time. Don't forget to check the website. Let me know what you think. Bye.